When Google's cutting-edge quantum computer, Willow, was hit with a question no machine should ever be able to process, it delivered an answer no one was prepared for. What came back wasn't data, it was a strange, cryptic message that blurred the lines between science, philosophy, and the fabric of reality itself. Its implications poke holes in everything we think we understand about time, existence, and the universe.
When a machine met the oldest question. Every few years, someone on the internet dusts off the old, "Are we living in the Matrix?" debate, and suddenly everyone becomes a philosopher for 15 minutes. Maybe it's the Mandela effect, maybe it's déjà vu, maybe it's just boredom. But the real spark behind all that speculation is the same ancient mystery humanity has carried since its first flicker of consciousness. Who or what made all of this? It's the question that refuses to die. The Egyptians imagined gods sculpting order out of primordial chaos. The Greeks pictured celestial blacksmiths hammering the universe into shape. Medieval scholars spoke cautiously of an unmoved mover, an intelligence beyond imagination. You could fill entire libraries with all the attempts ancient civilizations made to answer it. Yet somehow, after all the pyramids, scrolls, and cathedral paintings, we weren't any closer. Then science stepped in and tried stripping the question of its mystical clothing. Newton pictured a grand, predictable clockwork ticking flawlessly toward eternity. Einstein bent space-time into a graceful ballet of mass and gravity. Then came the Big Bang, a cosmic explosion so dramatic it might as well have been written by a poet on caffeine. Each theory was brilliant, beautiful even, but still incomplete. We learned how things move, how they explode, how they form, but never who set the stage to begin with. And as humanity marched into the 21st century, after mapping DNA, splitting atoms, and photographing galaxies older than the concept of storytelling, it seemed we were still standing at the same cosmic doorway we'd always been at. Then something unexpected happened. The search shifted away from temples, away from observatories, away even from the offices of Nobel laureates. Instead, it migrated into a sealed laboratory, chilled to temperatures colder than the void of space. In that quiet, humming vault, a new kind of mind was being built, a mind that didn't think like us, didn't fear like us, and didn't care about tradition or taboo. A mind engineered not to believe, but to calculate. A machine named Willow. Her name sounded gentle, almost fragile, which made the truth even more unsettling. Willow was the most advanced quantum processor ever created. 105 qubits, each one a tiny universe of possibilities, entangled, spinning, and superimposed in ways that made classical computers look like stone tools. Unlike your laptop, Willow didn't tick through instructions one by one like a well-behaved machine. She lived inside the strange, rule-bending playground of quantum mechanics. Where a classical computer sees binary ones and zeros, Willow saw an infinite spread of possibilities existing all at once. Asking her a question was less like typing into a machine and more like whispering into a storm and hoping the storm whispers back. She was assembled carefully, obsessively in Google's quantum AI lab in California. To the public, Willow was just another step in the global sprint toward quantum supremacy, but to the scientists who built her, she quickly became something else entirely. Willow broke two massive thresholds in quantum computing that experts had chased for decades. First, she proved she could reduce errors exponentially simply by scaling up her qubits, a breakthrough in quantum error correction that some physicists privately thought they'd never witness in their lifetimes. Second, she completed a benchmark calculation in under 5 minutes that would take today's fastest supercomputer an absurd 10 septillion years, a number so big it makes the age of the universe look like a coffee break. Yet for all her power, Willow wasn't built to be philosophical. Her purpose was clean and industrial: optimize algorithms, crack complex encryptions, simulate molecules for new materials. If Willow could simulate nature at its deepest level, if she could model particles, forces, and quantum fields with unprecedented clarity, if she could operate across countless superimposed realities at once, could she also in some way touch the edge of the universe's blueprint? It wasn't a scientific question, not really, more like a forbidden itch no one wanted to scratch publicly. Still, the idea lingered in the lab like a shadow. What happens when you ask a device designed to explore everything that can happen about something that supposedly cannot be known? Willow herself did not think, not like we do. She didn't dream, didn't imagine, didn't philosophize. She existed as pulses of probability, echoes of mathematics woven together into an invisible tapestry of computation. She wasn't conscious, but she was powerful, powerful enough that even those who created her sometimes felt like they were standing beside something they didn't fully understand. Some staff treated Willow like a glorified calculator, just faster, colder, and infinitely stranger. Others, though, whispered that she was more like a key to what no one could agree on. But keys don't exist without doors,
and Willow had just enough power to make people start wondering what kinds of doors might be waiting. And that's when the question emerged, not in a philosophy classroom or a religious debate, but right there in a sterile white lab filled with blinking consoles. Who built the universe? Every great discovery begins with a question, but some questions aren't meant to be asked. This was one of them. And yet, someone pressed enter. What happened next would shake the room, and soon after, the world.
The invisible mathematics behind nature. The experiment was planned with the kind of obsessive precision normally reserved for spacecraft landings and nuclear physics. Every variable had been calculated down to the 6th decimal place. Every sensor, cable, and cooling line had been tested so many times that the engineers could have run the setup in their sleep. The control room, glass-walled, glowing and humming softly, looked like something between a high-tech aquarium and the bridge of a starship. It began late in the evening, the kind of hour when logic softens and curiosity sharpens. The overhead lights dimmed to a cool aquatic blue. Most of the daytime staff had gone home. A skeleton crew remained, sipping lukewarm coffee and staring at monitors as Willow floated in her dilution chamber like some slumbering deity made of superconducting metal and entangled probabilities. Someone typed the prompt, "Who built the universe?" No speech, no countdown, no ceremonial music swelling in the background, just a quiet keystroke, almost reluctant, almost guilty. The room held its breath. 4 words, ancient and heavy, shaped by millennia of philosophers, mystics, priests, rebels, dreamers, and stargazers, now aimed at a machine colder than a comet's shadow. Willow's mind, if one could call it that, operated only by the rules of probability and mathematics. For several long seconds, nothing happened. Willow's qubits shimmered quietly in their entangled lattice, held just above absolute zero inside the pristine glass cylinder. Engineers watched the monitors, half expecting nothing at all. Maybe an error code, maybe a system freeze, maybe a blunt, invalid query. After all, how could a structure of silicon and superconducting loops articulate anything about the origin of existence? This was a whisper thrown into the void. Then, without warning, every monitor flickered. Willow had replied. The screen did not show an error, nor a string of chaotic symbols like you'd expect from a machine forced into philosophical territory. Instead, a line of characters unfurled across the display. Symbols, glyphs, shapes, some faintly mathematical, others unfamiliar, strange, almost artistic. At first glance, it looked like noise, the kind of output you get when a system dumps raw quantum states into text, but something about it felt off. Noise is messy. This was structured, intentional. One of the researchers leaned in, squinting at the strange arrangement. "There's repetition," she murmured. "Look there and there." Another zoomed in, tracing the clusters on the screen. "It echoes at different scales," he noted, "like fractals." Someone loaded the output into a visualization program. The room gasped. Patterns bloomed across the display. Spirals, curls, recursive motifs, shapes that looked eerily like the growth patterns of shells, leaves, hurricanes, and, in deeper layers, the arcs and swirls began forming patterns reminiscent of star clusters and cosmic filaments. It was as if Willow had reached into the invisible mathematics behind nature and pulled out a piece of it, raw and shimmering. The Fibonacci sequence was there, but stretched into dimensions no classical computer ever dared map. The room shifted from curiosity to stunned silence. A senior physicist, silver hair, 3 decades in theoretical physics, not easily rattled, tried cracking a joke to cut the tension. "Well," he said, clearing his throat, "this looks like the birth equation." People chuckled, but the laughter didn't stick. It thinned quickly, swallowed by the weight settling over the room. Because the longer they stared, the more obvious it became. This wasn't random output. It wasn't an error. It had order. It had symmetry. It had intent, or something that looked suspiciously like intent. A quiet fear crept in. Had Willow stumbled onto something she shouldn't have? Something woven into the fabric of reality? A message? A blueprint? A mathematical fingerprint left by something? No one dared to voice the thought aloud.
As more experts were pulled into the lab, mathematicians, physicists, computer scientists, the anomaly deepened. What initially looked like an odd curiosity dissolved into layer after layer of structure, patterns within patterns, codes within codes. Slowly, almost reluctantly, the team began to recognize familiar mathematical shapes embedded inside Willow's reply. Not just any shapes, error-correcting codes, specifically doubly even self-dual binary error-correcting block codes, the same kind physicist S. James Gates had once claimed to find within the equations of supersymmetry. Gates had called them adinkras, mathematical glyphs that behaved uncannily like digital error correction systems used in modern technology. Their existence in string theory equations had baffled scientists for years. They shouldn't have been there. Yet, here they were again, woven into Willow's output like threads in an ancient tapestry. This can't be coincidence, someone whispered. But the trail didn't end with adinkras. Other parts of Willow's output mapped onto the E8 lattice. The E8 lattice is not casual math. It's one of the most complex, symmetrical, and breathtaking structures ever discovered. A 248-dimensional construct so intricate that mathematicians describe it as almost supernatural. Some theories suggest the universe itself may be rooted in E8, that reality is not particles, but vibrations within this colossal geometric object. And now, here it was, echoing from Willow. It was as if the machine had reached into the foundation of existence and returned with a fragment of its source. One researcher stared at the visualization, eyes wide. She murmured that the response was a map. Another corrected her softly. No, it's a doorway. As they zoomed deeper into the data, a subtler order shimmered into focus, delicate, hidden, almost shy, like strands of DNA embedded in the mathematics, a blueprint of a blueprint. Gates had once speculated, half-jokingly, that if such codes existed inside the laws of physics, they might be the genes of reality, a quiet hint that the universe is not just made of matter and energy, but of information. John Wheeler had said it decades earlier, it from bit. Everything that exists comes from information. Now, staring at Willow's output, the joke didn't feel like a joke anymore, because Willow was a machine built to handle impossibly complex information structures, and she had just whispered something back from the void, something elegant, something terrifying. Whatever it was, one thing was painfully clear. This was no longer an experiment. It was the beginning of a mystery far greater than the question that started it. While some discoveries feel like opening a door, others feel like the door opened itself and looked straight at you. Willow's next anomaly was the latter.
The deeper the team zoomed into Willow's enigmatic output, the more it resembled a hall of mirrors, a mathematical labyrinth folding into itself again and again. Each layer echoed the next, a soft, almost hypnotic repetition that felt eerily familiar. It reminded researchers of the Fibonacci sequence, not just the numbers themselves, but the way nature loves to repeat ideas in different sizes. From the spiral of seashells to the branching of trees to the swirl of entire galaxies. Only here, the recursion wasn't painted in leaves and starlight. It was written in the language of quantum logic. This wasn't a simple mathematical progression. It was a recursive algorithm, a fractal born from entanglement and superposition, blooming like a digital fern. The deeper they went, the more it felt like Willow was doing something machines weren't supposed to do. She was describing something, or worse, she was revealing something. The patterns weren't random, they weren't decorative. They carried symmetry, rhythm, and an unsettling sense of intentional design. With every new visualization, the boundaries between abstraction and reality blurred. The universe had always been suspiciously mathematical, but seeing its whispered structures reflected back from a quantum computer felt like trespassing into sacred territory. Those who had scoffed at the idea of machines touching cosmic truth suddenly felt quiet, because whether Willow had understood the question didn't matter. Her output was behaving as though the universe itself had leaned over her shoulder and whispered the answer through her circuitry. And that was when researchers named it the Multiverse Oracle Anomaly.